To given positive integers n and k, and so you can choose any bits in the binary representation of n that is equal to 1, or you have to make a change to it to 0, and we have to return the number of changes, a count we can say, that needed to make a n equal to k. If it is impossible, return -1, right? If it is that, return the number of counts. So let's suppose we have given 13, right, and we have given 4. So 13 in the sense, you can see the explanation, right? So if we see the binary representation of n and k, so n we have 13, right, and for 13 it is 1 1 0 1, okay, and we have given k, that is we have 4, right? Here we have given 4, sorry. So for the 4 we have binary representation, you can say 0 1 0 0. I think 8421 we have the formula for where you can use this 8421 formula, and you can make till the you can say 16 bits, right, and then we have 16 32 like that we can make, okay. So you have to understand little operators things, like how we are going to implement this, right? So if you observe here, right, so in the bitwise operator that we have already talked about in the last video, so bitwise operator is this, and if we will make a representation of a and b, right? So if you'll see, this is a, we have 5, and we have b 7. So if we'll do OR operator, we'll get 7. If we have AND operator, we'll get 5. And pause this video and understand how we have done that. Otherwise, go and see my last video that we have already talked about this one. I don't want to waste your time, and because if you already have seen the video, it is a waste of time. So please go and see the video, okay. The next, we have already talked about the bit shift operator. We will get like this, right? If we have 13 1 1 0 1, and we have 0 1 0 0, right? So if we'll do bitwise operation, you will see the compare of the string, right? So when we'll do AND operator, right? So it is saying if we have n and we want to make or AND operator with the k, right? If it is not equal to k, right? If it is not equal to k, means this thing, this will come in the next slide. So that is why I'm trying to make you understand. We have given number of bits, we have given for 13s and 1, right? If we'll do AND operator, you will receive this. So if this case will come, it means we are not going to perform anything, because see, it is already coming like this, right? So you can see now we have it's right shift operator. If you'll do right shift of n1, you will get 6, and for this you will get this, right? How will you get? For the 13 we have given what 1 1 0 1. If you want to make one shift, so this letter will come here, right? So it will become 1 0 1 1. If you'll see this, it is a binary representation of 6, right? Oh, sorry, this will also become 0, right? So for the one shift, you will see we are shifting one integer from 1 to 1, it will become 0, right? Otherwise it will become like shift operator. If you'll do the shift operator for 4, you will get 2, right? So initial check that I was saying, if we have n equal to 13 and k equal to 4, right? And if we'll do representation like 1 1 0 1 it was, and this is I think 1 0 0 1, right? And 0. If you observe that, this will become, and if you do AND operator, you will get what 1 0 1 and 0, right? So this is nothing but your 4 means k. This is your nothing but your k, means it is saying we have to make an initial check if n and k, if you are making AND operator with the k, if it is not equal to k, right? If it is not happening, then we have to return -1. Why? Because if we perform AND operator with n and k, then a bitwise operation, AND operation will happen, right? And that will give you a result of k, right? That we can see here, right? So the purpose we have here to check if all the bits are 1, right, in the k. If there is all bits are if all the bits are 1 in k are also 1 in n, right? As you can see here, right? If any bits is coming 1 1 here, both side, right? So if k has any 1 bit where n has 0 bits, right? So in that case what will happen? It is impossible. Like if rather than this one, you can see the other one, right? So it is not matching. So it is impossible to transfer n into k, right? So it is saying if k has any 1 bits where n has 0 bits, so it is impossible to transform n into k. So without turning those zeros into 1, which is not allowed, right? If there is a 0, right, in top, right, and then we can make 1, right? So there is some you can say zeros, right, that we can make into 1. So if the n does not contains, right, then we will do what? We will return k, right, and then we'll modify the further programs. Okay, like now what we have to do, we have to check the countings, right? How many times we will change bits into other bits, right? Or like 0 into 1. So the while loop we will make and will continue until it reaches to 0, right? If it is reaches to 0, we'll stop moving while loop, as you can see, right? Rather than what we will do, we'll check AND operator and we'll say n, we have the n, and we'll check with the 1, right? If there is n is some value, right? Let's suppose we are talking about 13. 13 we have got 1 1 0 1, right? So if we'll do with the AND 1, means this is 1 0 0 0, right? So if we are making AND operator, so 1 1 is nothing but 1, rather than other elements is become what? 0, correct? Because we are doing AND, as you can see here, right? Here and is doing what? If we have 1, we will get 1. If there is any changes there, we will get what? Respective value, right? So I was here. Okay, so you will get the result like this. So if it is coming 1, means this is nothing but your 1. Okay, so this condition is saying if n and 1 we are making, means this is the 1 bit, right? This is a 1 bit if it is coming 1, and for k if it is coming 0, right? If it is coming 0, then we will do what? Count, because there is 1 and there is 0, then we can convert this, right? Otherwise we will not change, right? If it is 1 and here is also 1, then no need to change, right? So we have to see this condition and then we have to work, right? Then we have what? Count is plus plus, right? And we will find our bits and we will shift n and k with the 1, right? And we'll continue. So we are doing here right shift and with the 1 and the left shift with the 1 by bit we are moving next to next bit in each iterations, right? So let's see the program. So initial check you have to do to check there should not be a you can say there is a possibility that we can do changes, so it will not break the code, right? If it is n and k is not equal to k, it means what? We can do the changes, right? If it is equal to k, it means we will not we will continue, right? If it is not equal to k, we'll return -1. Okay, it should be n, right? It should be the value, right? Let's suppose if we have 5, right? So we are talking about what? 0 1 0 1, right? This is 5. And if let's suppose b have what? 7, right? So if we want to do what? 0 1 1 1, right? We were doing. So if we'll do AND operator between these two, right? What you will get? You will get again 5 here. How? 1 1 1 0 1 is 0 1 1 1, this is 0. So you are getting again what? You can say a. This is nothing but your a, right? Similarly, if you observe that this is a is nothing but your k, right? In this sense, what will happen? It will become coming 1 again, right? A again. So if this is the case, means we are how many changes you will do, you will not get your changes, right? And so we will return -1. But Apart from that, if it is not like that, then we can make a changes and it will work. But we have to make a change, we have to check like each bit we have as 1 and k have a bit of 0, right? So we will check with the 1 and what we can say 0. If it is matching, we will make a count and will shift one bit, we will shift, right, and we'll get the count. Okay, so I think you like this video, and for the time complexity and space complexity, please ping me in the comment box. If you really like this video, please hit subscribe this channel, and if you have any suggestions, please put me in the comment box. Thank you guys, thank you for watching this video.